Hey guys, today we're going to talk about a different type of coin problem. So we're still looking at the same lesson as yesterday, coin problems, but we're looking at examples where they're going to give you a total. So in example 3, they tell you that there's a total of 30 coins, and they don't tell you how many of each. So they'll say that there are nickels and quarters, but they don't tell you how many nickels, how many quarters. They just tell you that there's a total of 30 coins. So this concept is kind of like, imagine you had a box. I'm going to draw a box. And in this box, I told you that there are 50 pieces of chocolate, 50 chocolates. And this person over here took from the box and ate X pieces of chocolate. So the question is, how many are left? Well, if they ate X chocolates and there were 50 altogether, then in terms of X, you would say there are 50 minus X remaining left in the box. Okay? That concept could apply to when you have two types of things. So if you knew that there were, instead of 50 chocolates, imagine that there were, I'll switch colors here. Imagine that there were a certain amount of dimes. We don't know how many dimes. And we don't know how many quarters. And we don't know how many of each, but we know that there are a total of 50 coins. Same idea as the 50 chocolates. So now, it's kind of the same idea. You would say, well, if I have X of one kind of coin, let's say I have X dimes, then how many quarters are there? Well, it's kind of like the same concept as the chocolates. I have 50 minus X quarters because there were 50 coins altogether. Okay, and that's the idea of what we're working with for our let statements in these types of questions. So example 3 says, a purse contains $4.70 in nickels and quarters. In all, there are 30 coins. So I don't know how many nickels or how many quarters, but I'm going to say let X represent the number of, or the quantity of nickels. And I'll say quarters is going to be the total, 30 minus the X, minus however many nickels there were, will be my quantity of quarters. Now you could have let X be the quantity of quarters, and then 30 minus X would have been the quantity of nickels. You can switch that around and it's going to give you the same result. So remember from yesterday that this is quantity. This is just like there's 10 nickels or 8 nickels or 6 quarters. This is not the value of the money. So the value of the money comes from the fact that there are $4.70 in the purse. So our equation is going to represent value. It's going to say that all the coins add up to $4.70. But if I have X nickels, that's my quantity of nickels, and nickels are worth 5 cents each, then I'm going to multiply 0.05, 5 cents times however many nickels I have, X, plus if I have 30 minus X quarters, then 25 cents times however many quarters I have, 30 minus X, and that equals my total value of $4.70. So if you remember from yesterday, we're going to try to clear the decimal. Now, as you do this more and more, you can start to skip this step of multiplying by 100, and you guys can start to go straight into just expressing this as 5x plus 25 times 30 minus x equals 470. And then we're going to distribute. So we're going to have 5x plus 750 minus 25x equals 470. I'm going to combine like terms. 5x minus 25x is negative 20x plus 750 equals 470. Subtract 750 on both sides. I have negative 20x equals negative 280 divide both sides by negative 20, and you have x equals positive 14. So going back into your let statements, this tells you that there were 14 nickels, that's the quantity, and 30 minus 14, which is 16 quarters. Okay, so whenever they tell you that there's a total number of coins, like 30 coins or 50 coins, you set up let statements saying let x be the quantity of one type of coin, and then the total minus x is the quantity of the other type of coin. So let's take a look at another example. And at this point you could pause the video, and try it on your own maybe, and then check to see if you're doing it correctly. Okay, Sheila has 27 coins made up of quarters and nickels. If she has a total of $3.75, how many of each kind are there? So my total number of coins, my total quantity, this is my total quantity, is 27 coins. And I know that they're made up of quarters and nickels, but I don't know how many of each again. So I'm going to say let x equal my quantity of, and it doesn't matter which one you pick, I'll just pick the first one, quarters. So if I know there were 27 coins altogether, then 27 minus x, that's basically whatever's left of the 27 coins, is my quantity of nickels. And my value of my coins is $3.75. That's my total value. So my equation is going to be based on the value of your coins, but remember you have to multiply by what they're each worth. So quarters are worth 25 cents, so I have 25 cents times x, plus nickels are worth 5 cents each, so 5 cents times 27 minus x, which is the number of nickels, my quantity. I'm going to clear the decimal. I'm going to skip the step where I write times 100. I'm just going to go 25x plus 5 times 27 minus x equals 375. And I'll distribute 25x plus 135 minus 5x equals 375. Combine like terms, I have 20x plus 135 equals 375. Subtract 135 from both sides. I have 20x equals 240. X equals 12. So plug this back into your let statements. This tells you that there were 12 quarters and 27 minus 12, which is 15 nickels. That was your quantity. All right, so tonight's homework is going to be a couple of these types of problems, and it's all pretty much the same, and it should become like a routine. Okay, thanks, bye.